Hello everybody, welcome back. So this is the last portion in a different type of rocks. So in the previous lecture we discussed about the sedimentary rocks, and this one is the metamorphic rock. And as we discussed in the beginning, that the metamorphic rocks are formed uh, at the deeper part of the crust or the interior of Earth, and it is because of the under high temperature and pressure. So we'll see again the different type of metamorphic rocks and what are the importance of different rocks in CE, that is civil engineering. Okay. Now before just I start what we did in the igneous rocks and the metamorphic rocks, we looked at different mineral assemblages, and we looked at whether the color of the rock is darker or brighter, or maybe it is and that was basically based on the felsic and mafic minerals. And then we looked at the grain size and the textural features of the rocks. In both the rocks, that is sedimentary and igneous rocks, we looked at the different mineral composition as well as the grain size and the texture of the rocks. Okay, now here also we'll move ahead and different minerals which are altered from one mineral to another one, okay, due to high temperature and pressure. What different type of rocks we get, and that is basically the metamorphic rocks, and how the different textures are been formed in terms of when the rocks are subjected to high temperature and pressure. So again, starting with the previous slide, if you look at, this is one of the most beautiful monument, and this is from Taj Mahal. So you see the white rock behind this one is the marble. So marble is a metamorphic rock. So with this I'll start and then briefly we'll talk about that what exactly we discussed regarding the rock cycle. So we reached up to this in the previous lecture. We talked about the formation of the sedimentary rock, and when sedimentary rocks are subjected to high temperature and pressure, because if you move in the deeper part of the earth, then you will have high temperature and pressure. So if they are subjected to high temperature and pressure, they will deform, they will get buried, and then result into the formation of different type of metamorphic rocks, depending on what type of sedimentary rock is been metamorphosed. And further down, it will again melt, get into the magma chamber, and it comes out on the surface in form of again the extrusive igneous rock, or it may remain an intrusive igneous rocks. Okay. So this cycle continues, and we see the formation of the rocks, weathering of the rocks, solidification, and again subjected to deep burial under high temperature and pressure. So what is a metamorphism? Okay. So metamorphism is a change in form that happens in Earth's crustal rocks, okay, in response to changes in temperature and pressure. So this is the most important. So the temperature change in the temperature and pressure will result into the metamorphism of different rocks. For example, I am giving one is this the sandstone, if subjected to high temperature and pressure, will result into the formation of quartzites. Okay. So similarly, the limestone, if subjected to high temperature and pressure, it will result into the formation of marble. So the minerals got changed from mica to chlorite and all that. So this is the process in which we see the different type of metamorphic rocks. If you look at that how this sedimentary rocks are subjected to deeper burial, or they are subjected to high temperature and pressure at the deeper part of the earth interior, is mainly because of the ongoing tectonic movements. Okay. So when the plate subducts, it takes the surfacial material into the interior of earth, and which will be subjected to folding, shearing. Okay. So this folding and sharing also will result into the metamorphism, and a deeper part, of course, it has an advantage having the high temperature and pressure. So these are some of the examples which have been given, which says that deformed and intruded rocks in the mountains, and then they are subjected to fracturing and metamorphism. And for example, limestone, if it is subjected to metamorphism at the deeper part, it will result into the formation of marble. And then shale, which we talked about, these are all argillaceous rocks, okay, and these are we talked about the limestone are either from the dissolution or maybe the or formed because of the organic rich shells and all that, okay. So limestone is that which will result into formation marble, and then we are having shale which will be converted to slate, further metamorphism which will result into the formation of phyllites, and then schist, this one is there, schist, and then sillimanite schist and all that. This is a mineral here, okay, and mica and chlorite is again the minerals we are looking at. And then we are having sandstone. If it is subjected to metamorphism, it will result into the formation of quartzites, okay. And then again, if you are having the again crystalline rocks, for example, you are having granites, okay, then they are if they are subjected to metamorphism, they will result into the formation of gneisses. We'll see those rocks because again these rocks are having very typical characteristics, and based on that, what we say the foliated and non-foliated metamorphic rocks, we'll try to see that. So metamorphic rocks, when rocks are baked by heat of molten magma, that is an internal heat coming in, or squeezed by movement of huge tectonic plates, or by the pressure of overlying thick succession of rocks, okay. So you are having one, the deformation going on, subduction which is resulting, and then you are having the burial pressure from the top, all will result into the formation of metamorphic rock because of the conversion of one mineral to another mineral, that what we call the diagenesis, okay. Then they are altered, so minerals are altered or the rocks are altered incomplete, which result into the change in chemical composition also, okay, texture and structure. So this is the extremely important part. So under the internal heat, either they are squeezed or by the huge tectonic forces, tectonic plate forces, or by the overlying pressure of the overlying successions, the rocks are altered, which may result into the form change in the chemical composition, texture and structures, okay. These are termed as metamorphic rocks. So factor controlling metamorphism, of course the simplest way to understand the metamorphism is to remind the cooking effect, okay. So if you are having what you cook, that is extremely important. So if you say that I want to cook limestone and then have the quartzite, it is not possible. So you should know what you are cooking, okay. So depending on that, you will find the same as in the metamorphism process, okay. The end product will depend upon the initial composition and then the pressure and temperature, okay. So if you are at the shallow depth, you may not expect that you will have schist, okay, from directly or you may not have phyllite, you may have schist, okay. So from schist further you go down, then you will have the phyllites and all that we will see, okay. And then factors that controls or the influence metamorphism are one, the chemical composition of the initial rocks which has been put in, okay, and then intergranular fluid which we are having. So what is the composition of the fluids and all that, and then you are talking about the temperature and pressure at the greater depth and the time also, okay, fine. So type of metamorphism, this has been explained in a very simpler way, okay. What we have, we say, okay, fine, if you keep on increasing the depth, you are increasing the pressure, you are increasing the temperature, okay. So if you are subjecting the different rocks at high temperature and high pressure, the process which leads to that is termed as prograde metamorphism, okay, and which goes up to C, from A to point C. Now this process is like is because of the subducting plate or the material which has been subducted below the surface within the crust, and then time will come, the tectonic movements, okay, stop here somewhere. But when and after that, okay, if suppose you are having an uplift going on, in that process again the 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 pressure decreases, no doubt, but there is some increase in the temperature over here, but slowly it decreases, okay, but it doesn't decrease very smoothly. So even the prograde metamorphism continues up to the sea, and then you are having the uplift that is coming, the rocks are coming or exposed up to the towards the surface, where we will have again the temperature decrease, pressure decreases, and temperature also decreases. That is termed as the retrograde metamorphism. So metamorphism, or the metamorphic changes that occurs while temperature and pressures are rising with abundant intergranular fluid are termed as prograde metamorphism, and then metamorphic changes that occurs as the temperature and pressure declines, okay, so this is the retrograde metamorphism. Okay, so intergranular fluid plays an important role in process of metamorphism, okay, and these fluids may include some amount of gases, salts, and mineral constitutions dissolved from the host rock. Okay, now if the fluid are absent or available in very less quantity, the process of metamorphism is very slow. Okay, so there's also effect on that I was talking about, that the cooking process. Okay, so if you have less fluid available, then the process may be little bit slow, and few changes in the mineral composition will take place. Okay, so alteration of one mineral to another mineral will be in a slow process. Okay, so this also is important. Now the temperature, the source of the temperature is either from the magma or due to the depth factors. Okay, and this we have discussed in the beginning when we are talking about that how temperature and from where it comes. Okay, so internal heat is from the either the radioactive minerals or the radioactive material elements within the earth interior, or from the magma chamber we are having at the depth. Okay, so metamorphism usually result into change in mineral composition and the texture of the rock. Okay, so textural features will also change, and of igneous and metamorphic rocks which are subjected to temperature. So the temperature is as high as almost like you can say greater than 100 degrees centigrade, and pressure will be more than thousands of megapascal. So low grade metamorphism, we have to look at the temperature occurs at about 100 to 500 degrees centigrades, whereas the high grade metamorphism, you are having the temperature which are greater than 500 degrees centigrade. Okay, so these are the two types of metamorphism we term as low grade and high grade metamorphism. So depending on this, we will have different type of rocks which have been formed. So for example, if you look at this section, it shows that there's an increase in pressure you are having, and here you are having increase in temperature. Okay, so this area, that is the region of diagenesis. Okay, where the process start change in the mineral composition. Okay, so region of low grade metamorphism, and this is the region of high grade metamorphism, and finally you're getting into the region where the melting starts. Okay, so melting starts somewhere at around 800 degrees centigrades. So pressure is extremely important, and if you look at that, if you are having sigma 1, sigma 2, sigma 3, all are same. Okay, then what you will have is the uniform deformation. Okay, but suppose you are having, so this is under the uniform stresses, and suppose you are having difference in the sigma 1, sigma 2, so you are having high or maximum, minimum, and intermediate, then you will have directional deformation, or we can say differential stress. Okay, and so you will have the preferred orientations of the minerals which will be aligned almost perpendicular to the maximum stress. Okay, so pressure, what we take as a stress here, result into change in the textural parameters. Okay, so textures will change of the original rocks. Rocks are solid, we know that, okay, which can be squeezed more strongly in one direction if you are having differential stress, okay. But at the greater depth you will always see that the stress is uniform, okay. So at the greater depth of within the earth you will find that they are very much uniform, but close to the surface of the crust you will have differential stress. So you will find the rocks which are formed are having very preferred orientation of minerals, okay, and we'll see the example of that in the next slide. So texture in metamorphic rocks are the result of differential stress, okay, whereas the texture resulted from uniform stress are commonly seen in igneous rocks, because igneous rocks are crystalline, they get crystallized at the greater depth, as in what we see the intrusive rocks and all that, okay. So now, for example, development of different textures in the rocks of the same composition, and if you subject those rocks to differential stress, an example here is at the uniform stress, if you are having, you will find the formation of granite. Again, the granite is not an extrusive rock, it is an intrusive rock, hence you see the minerals are uniformly formed, okay. They are not showing any preferred orientation, I want to say that here. But if they are subjected to differential stress, then the minerals will get oriented parallel to the or perpendicular to the high stress direction, okay. So you have what we call as a granitic gneiss, okay. So this gets converted into the metamorphic rocks and they are termed as granitic gneiss. The composition more or less remains similar here. So under a differential stress, major as well as the mica grains, okay, so the major is quartzites and all that will be oriented parallel to the maximum stress direction, okay, giving rise to distinct thing. Okay. So this you will find that a preferred orientation has been seen. This is an example of granite, whereas this is an example of your gneiss, okay, and they are subjected to differential stress. There's again very much preferred orientation. You can see here the clasts here are oriented. So the stress direction, if you want to see, is something like this. They are compressed in this direction, okay, and we are having all these foliations which are been formed here, okay. These are all what we call the foliated rocks, okay, and this is we term this as in budines, okay. So type of metamorphic rock, if we have to classify based on the textures, we say either they are foliated rocks. So foliated, again we will have very definite cleavable planes, okay, as we have learned in the minerals, the different type of cleavages. Here also we will have cleavages or the cleavage planes which are been seen here, okay. So these are all foliations or the foliated rocks, but in terms of the non-foliated rocks you will not be able to see such type of planes, okay. So they are all massive rocks, okay. So they are non-foliated. So we have foliated and non-foliated metamorphic rocks which are classified based on the textures. So this figure, if you look at, on the left hand side you are having all the sedimentary rocks, on the right hand side you are having the metamorphic rock comparatively what we have here, okay. So for example, we are having clay here, which will, if they are subjected to metamorphism, we will have like foliations, okay, because the clay minerals will again have the sheet like features, and then on the deformation we will have the foliated rocks here. So we can have the formation of slate. So mudstones, if they are subjected to metamorphism, okay, so then we will see the development of cleavable surfaces, okay, and those cleavable surfaces will be easily you can break easily along that plane, okay. So the beddings will be created and the clay minerals will change to chlorite and muscovite micas, okay. So this will be will provide the weak foliations and an aligned preferred orientation, okay, of the bedding planes. So we have suppose this is the outcrop here of the sedimentary succession, when it is subjected to the regional metamorphism on the large scale because of the ongoing deformation, the material will get folded and will get lined. Okay, so you are having these are the bedding planes. These are the bedding planes here, but you have this preferred orientation. Okay, what we call the cleavage edges. Okay, so this will be seen when you look at the sample in hand specimen. And then further, if you are having the sedimentary rocks, like for example sandstone, okay, and you are having the grains, sand grains, or mainly quartz and other minerals, and you are having inter grain space, what we call the pore space. When they are metamorphosed, they will try to squeeze. No pore space is found anymore in that rock, and then what we see is the very beautiful locking between one grain and another grain, and result into the formation of a massive rock without seeing, we don't see any structure, texture in this, and these are all non-foliated rocks, whereas this one which we were looking at, they are all foliated rocks and these are non-foliated rocks. Okay, so in foliated rocks you will have very definite cleavable planes of weakness. Okay, so foliated and non-foliated rocks. So we'll see different type of foliated and non-foliated rocks in coming slides. Okay, so coming to the foliated rocks, when platy, lamellar or flaky minerals, okay, sheet silicate minerals, like the micas, like for example the biotite, muscovite, chlorite, etc., occurring in the rock orient themselves parallel to one another. Okay, so they will orient themselves parallel to one another, perpendicular to the direction of maximum stress. Okay, that will result into the alignment of the minerals almost perpendicular to the or we can say will have the preferred orientation of the minerals. So these are unpreferred minerals, like for example we are having granite here, but then got preferred along the definite plane or perpendicular direction of the maximum stress. Okay, we are having, so we are having randomly oriented orientation of minerals, and we see preferred orientation of minerals due to metamorphism. Same example, but this is because of the burial. We can say the sedimentary rocks here, what we are having, we are having slate which are formed because of the burial of the overburden. Okay, so we are having the compression here, and then these beds are, when having the greater depth, will have preferred orientation. Okay, and another example of the slate, if you look at in the close-up, you will find the edges are having very typical cleavable, okay, or the cleavage along which the rocks prefers to break. Okay, they have a lot of multiple cleavage. So this is a typical characteristic of slate. Okay, so slate is again fine grained foliated metamorphic rocks formed under low grade metamorphism. So they are not high grade metamorphism, we'll see. Okay, and they are formed from mudstone, shales or claystone. So these are sedimentary rocks, mudstone, shales and claystones, and we term this as an argillaceous rocks. So these are the plane of weakness. Then further deformation of slate, if you take, then what will happen? Okay, it will result into the further deformation, and we see more weak zones, and then you can see the wavy structure here. Okay, and this is typical of what we say phyllites. Okay, so these are the phyllites. So when the slates, when metamorphose further, will give rise to more foliated rocks known as phyllites. So first you are having shale, that is sedimentary rock subjected to low grade metamorphism, will result into formation of slate, and slate further metamorphose will result into the formation of phyllites. So it is characterized by wavy texture or the foliation. So this is a typical of the phyllatic rocks. Okay, so you will see this wavy structures if you look at in the hand specimen. Okay, formed under low grade metamorphism, again still we are not reached to the high grade metamorphism. So slate, shale, slate and phyllites. Okay, so in thin section, if you have to see then what you will be able to look at a very colorful picture, and we are having the colorful preferred oriented minerals, which are mica, and the darker ones are your quartz. Okay. So schist, again another metamorphic rock, is formed under intermediate to high grade metamorphism when phyllites are subjected to the higher pressure and temperature. They will result into the formation of schist. Okay. And schist, again we have the what we call the texture is termed as schistosity. So we will see the preferred oriented sheet of silicates, okay, and the minerals surrounded by that. Okay. So you will have from phyllite to schist we have. So we have slightly larger grains, and again we will be able to see a very similar or typical wavy structures here also, but not very much prominent as we have been looking at the in phyllites. Okay. So these are the nice, as we have seen, we are talking about the from granite to granitic gneiss. Okay. So parallel foliations, medium to coarse grained quartz feldspar mainly marked by lighter and lighter layers, and the darkers are the ferromagnesium minerals here. So these are gneissic rocks. So you will have some very typical darker layers which have been found in the gneiss. Okay. So non-foliated rocks, these rocks lack foliation. Okay. And the best examples are quartzites and marble. So quartzites, they are extremely massive, no cleavable plane you will find in this, and whenever you break this, it will be difficult and very hard. Of course it will break, but it is tougher than the other rocks. Okay. So if you break it, it will break within very irregular surfaces. Okay. So you can see this one here and this one here. Okay. They are absolutely not along the preferred plane as we see in the foliated rocks. Medium to coarse grain are made up of fused quartz grains. Okay. So they are having fused quartz grains, and the texture of this we termed as an granulose texture. Okay. So and they are very well interlocked. Okay. So if you see this in thin section, you can see the contacts between the different grains. Okay. Very much preferred contact and very prominent one. Similarly, like marble, again if you look at there is a close up of marble metamorphosed from limestone. I was talking about that limestone to marble, and that was sandstone to quartzite we are having. Okay. So we have medium to coarse grain grain size, mostly crystalline texture, shows tight interlocking of calcite grains. Okay. So that was we were having quartz mainly. Here we are having most of what we see is the calcite grains. Okay. Formed under intermediate to high grade metamorphism. So this is the best example of that. So two non-foliated rocks we have seen. Okay. And the best example in terms of the monuments, if you look at, is the Taj Mahal. Okay. So thank you so much. I will stop here and we will continue in the next lecture.